Good day, class. For our next lesson, we'll create a script again and we will name it as P1 underscore algebra. Okay, algebra. So, another advantage of using MATLAB is that it is easy to solve algebraic expressions using or literally how you compute or how you analyze algebra in actual here in MATLAB. Okay, to do that we need to make a variable, or we need to make the variable independent. Okay, what does it mean? In algebra, we use variables x, y, or z. Okay? Then, using those variables, we are doing expressions like this. So, x raised to 2 plus 2 times x. So don't forget the multiplication. Okay, to combine the coefficient and the variable. Then plus 4. If you run this, it will tell you that there's an error, and the error says that x is unrecognized. Okay, it is an unrecognized variable. Okay, to make it recognizable, give x a value, example 2. Okay, then let's put a semicolon and CLC. Okay, then run again, F5. As you can see, the answer, okay, when x is substituted, okay, to the function or to the algebraic expression, the answer will be 12. But in algebra, most of the time we don't substitute a value. We don't substitute a value very often, or we don't substitute a value to we don't substitute a value instantly to solve an algebraic expression, especially if there are too many algebraic expression, and if you will use algebraic expressions for different applications. Okay, here x is not independent, or the variable x is not independent. It is dependent, okay, to what we will give value to it. Okay, to make a variable independent, we will use the command or the command syms or syms. Then you don't need to have a close open parenthesis, just put the variable you want to become independent. So what will happen here if I run this? Before I run this, I will clear all, then CLC. Okay, to erase the earlier value of x. Now x has no value, it is an independent variable. If we run this, okay, this expression will become an algebraic expression. Then if you prettify this, okay, let's prettify. Let's use pretty. the answer. So CLC again. Then F5. Okay. We will have an algebraic expression, the same with the algebraic expression we write in our algebra classes. Okay, so if we copy this and put in a Word document, okay, we can have here a text of x squared plus 2x plus 4. Just edit this. Okay, let's edit this. Then we have a text form of the algebraic expression from MATLAB. Okay, a prettified version. A version that is the same with how we write algebraic expressions. Okay, so let's make this prettified answer into comment. Okay. Next. What if you want 2 or more variables? Okay, 2 or more variables. You can make, or you can do this. Okay, sims A, B, C. Okay, if you want 2 or more independent variables, just add them. Just add spaces. Okay, they will become independent variables. Okay, so let's remove this. That's clear. Okay, let's look at what is the size of our values. It is still 1 by 1. So this is still a 1 by 1 matrix. Okay, so clear all. CLC. Next. Okay, let's write A is equals to, let's say, x raised to 3. Okay, then B is equals to 2x. Okay, let's say A is equals to x raised to 3, B is equals to 2 times x. Oh, sorry. Okay, then C is equals to A over B. So what will happen here? So this will be x cubed over 2x. MATLAB follows the rules of algebra, and MATLABs understand that this is a division of algebraic expressions. So it means it will factor out the x at the denominator. Okay, it will factor out this x at the numerator. So this will become x squared over 2. So let's try. Okay, F5. Sorry. Let us make this let's put some semicolon here. Okay, so let's go F5. Okay, so A is equals to x raised to 3, B is equals to 2 over x. So the answer is x raised to 2 over 2. Let's prettify the answer. Pretty C. Okay, CLC. Then F5. Okay, so it's a prettified version, x squared over 2. Let's try addition. Let's try addition. Okay, let's try operations. Okay, let's make sims y and z. So we have independent variables x and z. We have here x. Okay, let's add other variable. Let's name it D. Okay, D. Okay, D is equals to raised raised to 2 minus 3x 3 times x plus 4, and b is equals to x, sorry, not b, y is equals to x raised to 2 plus plus 2 times x minus 5. Okay. Then, let's prettify them. Okay. Pretty. Okay, let's do this later. Let's make a let's make z is equals to d plus y. Okay. So pretty d. Okay. Pretty y and pretty z. Pretty z. Okay, let's make this. Oh, sorry. Let's not make that done. Let's try to run this. Okay, F5. Okay, doesn't work. What's wrong with y? Algebra. And like, oh, it's a capital letter X. Sorry. Again, CLC. Then F5. Let's see if, oh, it's already fine. Okay. So x squared minus 3x plus 4 and plus 2x minus 5. Then addition. Okay, so 2x squared minus x minus y. So let's try to what do you call this? Subtract. Okay, let's add other variables. Uh, let's add A, B, C, D, X, Y, Z, U, and V. Okay, U and V. Okay, U is equals to D minus Y. D minus Y. Then, V is equals to D multiplied to Y. Okay. So let's see what will it be look like. Let's copy this. Let's make this pretty U, and the other one is pretty V. Okay, let's see what it will become. F5. Okay, algebra. Okay, so the answer for V, sorry, the answer for U, so D minus Y. Where's U? Oh, U is 9 minus 5x. Oh, U does, this did not become prettified? Why? Oh, it became prettified. Hmm. Oh, I forgot something. Oh, yes, I'm right. So the answer for U is 9 minus 5x. Let's see. So D. So this will become 0. Negative 5. Am I right? Then 4 plus 5, 9. Oh, yes. 9 minus 5x. That's right. Then the multiplication. Oh, it doesn't multiply each other. It is not multiplied using FOIL method. So we have here a way to do the FOIL method. Okay, let's go back to the multiplication problem. Multiplication of polynomial. Okay, let's make this semicolon. Let's put some semicolons. Okay. Okay. So if you are multiplying a if you're multiplying polynomials, use the syntax expand, close open parenthesis, then you multiply the polynomials inside. Okay, d times y. Okay, let's see how it looks like. Okay, sorry. Command window is populated. F5. Let's see how it looks like. Okay, it looks like a fourth degree of fourth degree algebraic expression. Okay, so we may check if it's right. This is our where is our oh, it's not here. Why it's not here? This is our d and y. Try to use FOIL method and see if the answer is this. Okay, x raised to the fourth minus x raised to the x raised to 3 minus 7x squared plus 23x minus 20. Okay. So based from the outside. Okay. The first and the last term. So it will become x raised to 4 and negative 20. So it is right. Okay, try to check this on your own if the answer is correct. Okay, so this is one of the advantage of or the one of the good advantage of MATLAB. We can solve algebraic expressions. Okay, actually we can also solve calculus expressions, but I think we have no time with the calculus. Okay. We are more interested in matrices in robotics. Okay.